now we are going to start a new chapter, volume and surface area of solids. In this chapter, first we are going to take a solid as cuboid. So there are certain formula that you have to remember to solve the exercise. So one by one we will explain the formula. Now first one is volume. So what is volume of a solid? So in scientific language, if you understand, in physics also you must have done, what is a volume? Volume is the space occupied by a solid. That space is called its volume. So now here we have taken a cuboid. So volume of a cuboid will be the space occupied by different dimensions, different length, breadth and height. That space is called its volume. So here it is a cuboid I have taken. This is the length of the cuboid and this side as the breadth and this is a height. So what is the formula for the cuboid? So the first formula of a cuboid is length into breadth into height. If you multiply all the three dimensions, this is a three-dimensional solid. If you multiply all the three dimensions, length, breadth and height, it will cover the whole space occupied by this cuboid. So this is the first formula that is to use. The next one is the total surface area. So what is the total surface area? I just show you one object. With the help of that object, you can understand what is the total surface area. Suppose this is the book. It is in cuboidal shape. So total surface areas means, first you understand how many faces this cuboid has. This is a cuboid. First face, top, second face, its bottom. Two faces, one face this side and similar faces opposite to this face. So two faces, this, four face. Now one face is this one and another face is this one. So all together if you count, a cuboid has 6 faces. Now this is the length of the book, okay, and this is the breadth of the book. And if you see this thickness of the book, this we will take as the height of the book. So there are 3 dimensions, length, breadth and height. These are the 3 dimensions. There are faces. First, if we take this face only, which 2 dimensions are involved in this face? This is the length and this is the height. So length and height. If we have to find the area of this face, here you can see each face is a rectangle. Yes, this is a rectangle. So each face is a rectangle. So if we want to find the area of this face, which is a rectangle, which 2 dimensions are involved? Length and height. Okay. Now if we go along this face, which 2 dimensions are involved? Because this is the breadth of the book. This is the breadth of the book and this is the thickness, that means height. So area of this face is breadth into height. Now if we see the top of the book, which 2 dimensions are involved in this rectangle? This is the length of the book, this is the breadth of the book, length and breadth. So area of this face will be length into breadth. Now all these we will take twice because each face has one more face opposite to it, that is equally the same as the top. So top and bottom 2 faces, this and opposite face. So each face area will be double. So total surface area will be twice of each type of the faces. So 2 into. First we are taking this face. So this is the length of the cuboid, means this book. So length and this is height. So length into height is the area of this face only, this one. So length into height. Plus now area of this face. Which 2 dimensions are involved in this face? This is the breadth of the book and this is the thickness or height of the book. So in this face there are 2 dimensions, breadth and height, and similar faces they are exact the same. So one and 2. So twice of breadth into height. So this you can take breadth into height. Plus. Now the third face. These two faces we have taken. Now the third face is this front page. So what are the dimensions which are involved in this? Here it is the length of the book and this is the breadth of the book. So two dimensions on this face. These are length into breadth. So formula will be length into breadth. Okay. So this is the formula for the total surface area. If we use this formula, that means this whole area, outer area of this cuboid we can find. Now the lateral surface. What is the difference between the total surface area and lateral surface area? Lateral surface areas are the areas along the side of the cuboid. Means length and breadth only. So in this lateral surface area, we will exclude the top and bottom area of the cuboid. This is excluded. So top and bottom area is length into breadth. If you exclude length into breadth from the total surface area, you will get the lateral surface area of the cuboid. So we can write the formula. This is again twice of, because two faces of same kind. Remove this L into B. So this is length into height plus breadth into height. This is the lateral surface area. From this formula, you can take H as common. That way also you can write the formula. So the formula now is converted in this form. 2 into H in the bracket length plus breadth, because here length will remain and here breadth will remain. So this is the third formula for the cuboid lateral surface area. Same area formula you will use when you have to find the area of 4 walls. Suppose this is a room. So if you have to find area of 4 walls only. So 4 walls means the top and bottom areas, the floor area and the roof area you will not include in this. So here what the formula you get, area of 4 walls is the same. So area of 4 walls is same as the lateral surface area, 2H into length plus breadth. Okay. So area of 4 walls means excluding the floor area and the roof area. You will not include. So these are the formula, and the last formula that you have to use, the diagonal of a cuboid. Diagonal formula. Diagonal formula means, suppose this is a rectangle, this is a plane figure. So this is the diagonal of that plane figure, but because this is the 3-dimensional figure, so you will understand it like there is a stick, long stick, and you have to place that stick in your room, whose one end should touch the ceiling of the room and another end should touch the opposite point on the floor. So that way you have to place the stick in the room. So that is the diagonal of the cuboid. So what is the formula for such diagonal? L square plus B square plus H square. This formula you can use to find the diagonal or the longest pole that can be placed in a room. Here in plane figure also, as you know, this diagonal is called the hypotenuse, because this is 90 degree. So this is called the hypotenuse. And as you know, hypotenuse is the longest side of any plane figure. Same way, that pole will be the longest if you place in a room whose one end should touch the ceiling and another should touch here. One pole, one end here, and another end of the pole should touch this way. If you place the pole like this or the stick like this, this is the diagonal of the cuboid, and this formula you will use to find the value of the diagonal. We are going to start from question number 1. In this question, you are given the length of a cuboid 24 centimeter, breadth 16 centimeter, and the height 7.5 centimeter. You have to find the volume, total surface area and lateral surface area of this cuboid. See children, before you start, you should check whether all the dimensions are, all the units are the same. Length centimeter, breadth centimeter and height centimeter. In this question, all the units are same. But if the units are different, like this is in meter and other units are in centimeter. So first you should make the unit same. Meter converted into centimeter by multiplying it by 100. 1 meter is equal to 100 centimeter. So you should know the conversion also. And or you can convert centimeter into meters by dividing this number by 100. Anyways, you have to make the unit same. Okay. Then only you should start to solve this. So now first quantity is volume. So you should write the formula always. This is mandatory for each quantity. So for the volume, you should write the formula length into breadth into height. Now put all the values. Length 24 centimeter, breadth 16 centimeter and height is given 7.5 centimeter. Okay. Now multiply all these numbers. So you will get 2880. Now when you multiply you will get 2880. But you should write the unit also. Unit is mandatory. For each quantity unit is mandatory. So what will be the unit for the volume? See here length you have taken as in centimeter. Breadth is also in centimeter and height is also in centimeter. So as many quantities you are multiplying, as many dimensions you are multiplying in the solution, that will be the unit of the final unit of the quantity. So 3 centimeters you are multiplying here. That means the unit of the volume will be centimeter cube. Okay. So this is volume of the cuboid. Now we have to find the total surface area. See children, if total surface area or only surface area is given, you will always find the total surface area. If it is given, find the surface area of the cuboid, then also you will find the total surface area. But if lateral is given, lateral surface area is mentioned in the question, then only you will find the lateral surface area. Otherwise it is total surface area. So for the total surface area, first you will write the formula, that is 2 into length into breadth plus length into height plus breadth into height. Okay. Now put the values. Length 24 into 16, breadth length 24, height 7.5 plus breadth 16 multiplied by height 7.5. Okay, we have substituted all the values. Now multiply this. So if you multiply these numbers, you will get 2 into 384 plus 180 plus 120. Now you add all them and multiply it by 2. So you will get the answer 1368. If you add all these numbers, you will get 684. And when you multiply, you will get 1368. This is the total surface area of the cuboid. Now, what will be the unit here? Area is a two-dimensional quantity. So, two-dimensional, how it is two-dimensional? How many dimensions you are multiplying here? So, here you are multiplying length into breadth, 2 dimensions, centimeter into centimeter, length into height 2 dimensions and breadth into height 2 dimensions. So means in this formula you are multiplying 2 dimensions. So for each dimension centimeter and other dimension centimeter. So 2 centimeters you are multiplying here. That means the unit of the total surface area will be centimeter square. So remember, always the area unit is centimeter or meter square. Now the third quantity we have to find, which is lateral surface area. So lateral surface area formula, now we will write. So what is the formula for lateral surface area? First we will write the formula. Lateral surface area, this is equal to 2h into length plus breadth. This is the short form of the formula. In short, now you can put the values. So 2h means 2 multiplied by h. What is the value of h? 7.5 into length is 24 plus breadth is 16. Now when you multiply all this, you will get 600. Now what is the unit of this lateral surface area? Again you are multiplying 2 dimensions. How 2 dimensions? Length and breadth, because being added here, and multiplied by, so you will count this addition as a single dimension, and you are multiplying by height. So 1 dimension here, 1 dimension here, that means 2 dimensions. So you are multiplying 2 dimensions here. So again the unit will be centimeter square. So always area unit is centimeter square. So now here we have found all the 3 parts of the questions. We will do the next question now. Now this is the next question, number 6. In this question you have to find the length of the longest pole. Length, breadth and height of the cuboid is given to you. So as I have explained you, longest pole means the diagonal of the cuboid is the longest dimension. So indirectly it is given in the question, you have to find the diagonal. This you have to understand. Longest pole means the diagonal of the cuboid. So all the dimensions of the cuboid are given. So you directly you have to use the formula. So first you will write the formula. Diagonal formula is, diagonal is equal to square root L square plus B square plus H square. Now put all the values here. So L square means 12 square plus B square means 8 square plus H square means 9 square. Now you take the square. 12 12s are 144, 8 8s are 64, 9 9s are 81. I hope you understand the square. If it is 8 square, that means 8 into 8, which is equal to 64. So square means multiply the number by itself. So here, if you add all these numbers, you will get 289. Okay. So square root of 289. Square root of 289 is 17. So the value of this diagonal is 17. Now what will be the unit of this diagonal? Because diagonal is a single dimension. So single dimension means whatever unit is given in the question, the same unit will be of the diagonal also. So diagonal will be 7 meter. This is the answer for the diagonal. So this way you have to do the question, direct formula based questions. Some other questions we will take from the exercise. The similar questions you can try.